Can you solve this algebra challenge? Here's the question. Solve for the real value of x that satisfies this equation 3 raised to the power of x plus x equals 10. Now you can pause this video if you want to give this problem a try. Now suppose you pause this video. Now let's see if you got the correct answer. Alright, so first let's observe this equation. Now the left hand side is 3 raised to the power of x plus x, and the answer is 10. Now if x equals 1, so 3 raised to the power of 1 plus 1, this is just 4. So this is less than 10. And if this x is 2, x equals 2, 3 raised to the power of 2 plus 2, this is just 9 plus 2, or simply equal to 11. So this 11 is greater than 10. So our intuition, the answer to this question is somewhat between 1 and 2, but close to 2. But not 2, of course. Now the question is, how do we get this value? Also, since this is strictly increasing and this is a constant, so definitely we have only one possible solution for this question, real solution to this question. So how to answer this kind of question? And to answer this, of course, we will use what we call the Lambert W function. So the Lambert W function is a special function, and this is also known as product logarithm. Now, to make this simple, if we have an equation y multiplied by e raised to the power of y equals x, and we take the Lambert W function on both sides, if we have this form y multiplied by e raised to same function y, the left-hand side is just the variable y. And it makes y equals Lambert W function of x. Therefore, our goal in this question is to rewrite our equation in this form y multiplied by e raised to the power of y, or any function multiplied by e raised to the same function. And if we take the Lambert W function on both sides, we get this function y. Alright, now the question mark is, how do we get in this form? Alright, so to answer this, let's subtract x on both sides. That's the first thing we need to do. And then let's divide both sides by 3 raised to the power of x. Now, the left hand side is just 1. We all know that. And now, let's use some laws of exponent. If we have 1 over b raised to the power of n, it must be equal to b raised to the power of negative n. So this is just 1 over 3 raised to the power of x. So we can rewrite this as 3 raised to the power of negative x multiplied by 10 minus x. Now, here's a good thing. We have here minus x and we have here minus x. Now, the only thing is this 10. So how do we get this 10? And to do that, we will use this concept of loss of exponent. If we have the same base, b raised to n times b raised to m must be equal to b raised to n plus m. Now, we can combine the exponent by multiplying this with the same base. So why not? Let's multiply the left-hand side by 3 raised to the power of 10 and the right-hand side by 3 raised to the power of 10. Now, this expression 3 raised to the power of 10 times 3 raised to negative x, if we combine this, this is just 3 raised to the power of 10 minus x. Now, we have the same expression 10 minus x. Alright, but this is 3, not e. If this is e, then we're done. But this is 3, not e. Alright. Now, on the left-hand side, 1 times 3 raised to the power of 10. This is just 3 raised to the power of 10. Now, let's rearrange some terms a little bit. Very quick. Let's move this 3 raised to the power of 10 on the right-hand side. Now, same thing, 10 minus x and 10 minus x. Now, how do we get this 3 becomes e, or to turn this into an e? Now, let's focus on this identity. If we have a constant b, we can write this as e raised to the power of ln of b. because take note, this ln is base e. So e raised to the power of ln b to the base e, this is just b. So if we focus on this 3, using this identity, we can rewrite this 3 as follows. We have e raised to the power of ln 3. Now, using some laws of exponent, we know we can multiply this to exponent, because if we have b raised to the power of m raised to the power of m must be equal to b raised to the power of n times m. So this expression right over here, we can rewrite this as follows. We have e raised to the power of 10 minus x multiplied by ln 3. Now, we have now e and this function 10 minus x multiplied by ln 3. But in this case, we have only 10 minus x. We don't have ln 3. So why not? Let's multiply both sides by ln of 3. Now, we have the same thing, 10 minus x times ln 3 multiplied by e raised to the power of 10 minus x multiplied by ln 3. At this point, we are now in this form y times e raised to the power of y. So we can now take the Lambert W function on both sides, because that's our goal. And we know if we get the Lambert W function of this expression, we get this just y, or simply 10 minus x multiplied by ln of 3. So the left-hand side is just 10 minus x multiplied by ln 3. It must be equal to the w, or Lambert W function, of 3 raised to the power of 10 multiplied by ln 3. And at this point, we can now easily solve for the value of this x. First, let's divide both sides by ln of 3. And then, let's add x on both sides. Now, let's subtract both sides by Lambert W function of 3 raised to the power of 10 times ln 3 all over ln 3. And there you have it. The value of x is in your screen. We have 10 minus w of 3 raised to the power of 10 times ln 3 all over ln 3. That is the value of x that satisfies this equation. And let's see, what is the value of this number? So let's type this in the Wolfram alpha. So we have 10 minus, again, this w is product log, or the Lambert W function is also known as the product logarithm. So product log of 3 raised to the power of 10 times ln 3 all over ln 3. And if we get this value, we have 1.9036877, and so on and so forth. And our observation is correct, because this number is less than 2, but it is close to 2. Therefore, given this equation, 3 raised to the power of x plus x equals 10, wherein x is a real number, then the value of x must be equal to 10 minus w, or the Lambert W function of 3 raised to the power of 10 times ln 3 over ln 3. And as always, we are done.